A piece of general information as we take a look at section 2.6 on piecewise functions. This is the first section that proves pretty challenging for most students. So that being said, let's take a look. To start off, let's say we have these two equations. They're both in slope-intercept form, and we want to graph them both on a single graph. So for our first equation, we have a slope of 1, or I'm sorry, a y-intercept of 1, and a slope of 2. All right, so looks like this, at least roughly speaking. And the second one, we have a y-intercept of -2, and then a slope of -1, so going down 1 over 1. All right, looks like this. Okay, so now in a piecewise function, there's going to be a bit more restrictions. So it's going to say something like this. We're still going to have both of these lines, but they're only going to exist in certain parts of the graph. So we're going to have sections saying something like this. We have our first line, y equals 2x plus 1, or f of x, if it's a function instead, equals 2x plus 1. And it only exists where x is less than 0. Which means everything to the left of this line is the only spot that graph actually exists. Now that was the red graph, okay, which means that everything to the right of that line isn't actually there. This all can be crossed out. All right, now for the bottom one, it says it exists only for x is greater than or equal to 0, which means everything to the left of that line isn't actually there. Okay, so that green line is the dividing line. To the left of it, we have the red line. To the right of it, we have the blue line. And this ends up being the end result. This is our solution for this piecewise function. It's called a piecewise function because it's made up of pieces of different equations. Now, one thing to point out is that on the previous slide, we had this green line separating the two lines. Okay, and if we look at the red graph, we can see this circle here at the end of it, and that's because we have an x is less than 0. Just like when we have the less than sign on inequalities, we use an open circle. We do the same thing with graphs. At the start of it, we have an open circle. This one has a greater than or equal to sign, which is why we have this closed. In this next graph, it's a bit more difficult because we have 3 parts, but we do it the same way. The first part is f of x equals x plus 3. You can always think of these as just y equals instead of f of x equals. So y equals x plus 3. Let's graph the whole graph to start off. All right, so we have a y-intercept of 3 and a slope of 1. All right. So it looks like this to start. All right, the second graph is y equals 2, which means it's just always 2. It's a horizontal line. And then the third graph, y equals 3x, starts at the origin, up 3 over 1. All right, so now let's break this up into the parts. Okay, so that first graph, the red one, only exists to the left of -2. Okay, everything to the right of that that red line doesn't exist. Okay, the green line exists between -2 and +1. So in this middle section here. And then the blue line only exists to the right of +1. Okay, anytime we see a less than or equal to sign or greater than or equal to sign, we use a colored circle at the end of that line. And anytime it's a less than or greater than sign, we use an empty circle. Right, so our completed graph would look like that. Sometimes we're going to be given the graph and we're going to be required to work backwards and come up with the equation for the piecewise function. So let's say we start with this line on the left here. Okay, we need to come up with the slope and the y-intercept for that line. Now the slope is easy enough. We can just count it, and we can see that it's going down 1 over 2. Okay, y-intercept, let's just continue using that slope. If we go another down 1 over 2, we can see it's going to intersect the y-axis at -2. All right, and that's going to let us write our equation. So -1 over 2 is our slope, y-intercept -2. Okay, next thing to figure out is exactly where that function exists. So it only exists to the left of -2. Okay, so it exists everywhere x is less than or equal to -2. It's a less than or equal to sign because we have a colored in circle to start that line there. All right, next up in the middle here. Okay, if we just count the boxes that's traveling, in the middle it's moving down 4 and over 2, so that's our slope. And we can simplify that to a slope of -2. Okay, it crosses the y-axis at the origin, which gives us an equation of y equals -2x. Okay, and we can see pretty simply that that exists in between -2 and 0, and it has empty circles on both lines, so less than signs without that line or equal to line underneath. Lastly, okay, we have this line on the bottom here. Okay, y-intercept is -3, and it looks like it's going up 1 and over 4. So y equals positive 1/4 x minus 3, and this exists for everything where x is greater than or equal to 0. Okay, all that gets put into one piecewise function. Here's one more just for the practice. Anytime we see a horizontal line like we do on the left there, that's just a number with no x. Okay, so in this case the number is 0. It's just y equals 0, where f of x equals 0. And the line that's separating that is just x is less than -3. Okay, in that middle section, okay, we're talking about in between -3 and 1. Okay, we have a less than or equal to on the left because that one's colored in, but just a less than sign on the right. This is a 1 over here. All right, we wanted the equation in between these two. So it looks like it's going down 1, 2. So it's going down 2, and it's going over 1, 2, 3, 4. So this is a slope of -1/2. Right now we don't know, or we're not required to write this in slope-intercept form. Right, we could, but let's just say we want to put it into point-slope form instead. So I'm going to pick a point. Let's say I pick this one. This is 0.11, and I'm just going to put it into point-slope form. Y minus 1 equals -1/2 times x minus 1. We can leave it like that, or if we needed to switch it into slope-intercept, we could. Okay, lastly, this one on the right here. Okay, we can extend it to get that y-intercept, so it's intersecting at 1, and it's going up 1 over 1. Okay, that's our full piecewise function.